Very much, Bashad. Hello, everyone. I'm Atique Hashmi, as Bashad did my bio introduction. So today I have this auto lubrication system presentation. And this presentation is, so I have not included any super technical stuff like designing and costing or anything. It is just basically introduction to auto lubrication systems, components, type of systems. So the agenda.
You are mute. I think you click on the
Oh,
mute.
yes,
Yeah.
I just saw that. Sorry about that. So the agenda for today's presentation would be auto lubrication system definition and purpose, benefits of auto lubrication system versus manual lubrication, types of auto lubrication system, main components, and then we will discuss single line series progressive system, single line parallel system, and then the dual line systems. There is another system called single point auto lubers, which I haven't included in this presentation just because of the time constraint we have. And then we would have some time for question and answer. But again, if you have any question about any specific slide, any specific portion of this presentation, please feel free to ask. Um, so auto lubrication systems are basically, they're also known as centralized lubrication system, are mechanical devices designed to dispense precise quantities of lubricant to multiple points within machinery during operation. It is from Wikipedia. And before I go in the detail, just so you know that this is a very vast subject, and so if you don't find anything which you are specifically looking for, please feel free to send me an email or STLE, anyone in STLE Toronto section an email about any question if you have, and we'll be happy to answer your question. So purpose, manual lubrication at optimal interval is often impractical due to human resource constraints, limited time, and the inaccessible location of lubrication points. And this is true when there are so many lubrication points on a very large machine or a mobile equipment when it is working. It is quite difficult to stop the equipment or the machine just to lubricate. So, and the production cycles, machine availability, and workforce availability often dictate lubrication intervals, which may not be ideal for machine performance and longevity. Automatic lubrication systems ensure optimal lubrication during operation. So you don't have to stop the machine and stop the production. Okay. There are several benefits of automatic lubrication system over manual lubrication. The first and foremost is safety. So when you have an auto lubrication system installed on stationary equipment or the mobile equipment, you don't have to climb around machinery or you don't have to reach inaccessible areas to lubricate the bearings. An automatic lubrication system will do it for you. And efficient lubrication, lubricate while the machine is running. No need to stop the machine for lubrication. Apply in a small, carefully control amount more frequently. And I will discuss more about what does it mean and how we decide what type of valves we are assigning to any equipment. And then another benefit is better housekeeping, less chance of spillage and leakage. Longer machine life because bearings are continuously replenished with grease, less downtime, reduced maintenance, and lower power cost. Not every auto lubrication pump is run on air. but many auto lubrication pumps operate on air. So less friction in the pump, fewer moving parts, so you don't have to change pump very often. Types of automatic lubrication systems, single line, series, progressive. We will see in detail. Single line parallel system, dual lines, single point lubricators, oil circulation systems, chain lubrication system, mist lubrication. But in this presentation, I'll just talk about only single line, series progressive, parallel, and dual line. And then the power sources. The most common power source is air because it's mostly available at many locations, many industries. And then electric, it could be AC, could be DC. For example, if you are installing a auto lubrication system on heavy equipment, mobile equipment, then the mobile equipment's battery, DC battery, would be used as the power source for the auto lubrication system as well. And when the power source is AC, then that power source can be used to run the pumps as well. And then the hydraulic. You won't see hydraulic very often, but they are installed in industry. And then the controllers. A controller runs a scheduler or program to dispense lubrication on regular basis. Some pumps have built-in controller or timers, but many systems use a standalone controller that's separate from the pump. And we'll see in the components of the auto lubrication system. And industrial auto lubrication systems are also controlled by PLC, and then you can connect the PLC to the pump. So PLC will dictate pump when to turn on, when to turn off. It will be programmable. So any questions so far? Okay. Cool.
Nothing on the chat. I don't see any raised hands. So continue, please.
Thank you. Main components of auto lube system, and just keep in mind, accessories are so many, but I have included the main components of auto lube system. Starting with the controller. This one is the controller. As I said previously, it could be timer, it could be PLC. It determines the operation cycle of the pump. It will turn pump on and off, and it has to be programmed. Like even if it is a standalone controller or built-in timer, it has to be programmed so it can run pump on cycles. Then the pump itself, it could be air, electric, hydraulic. It delivers lubricant under pressure. And then the third main component would be the supply line. Supply line would supply lubricant from the pump to the main divider block. And one thing I want to say is that there are so many different names in industry of these distribution blocks. So you will listen distribution blocks, divider blocks, and there are some other names which I don't exactly remember. But if you hear me saying one name, this means my training was done with that name. So distribution divider valves or injectors, they meter the lubricant to the feed line, through the feed line. So the fifth element or the fifth component of the distribution system or auto lube system is a feed line. So this is a secondary or primary or master divider block, and I'll explain why we need secondary and primary divider blocks for the system. And then the feed lines are the lines which actually take grease from these blocks, from the primary blocks to the lubrication point, to the bearing, to the gear, wherever it's needed, and the accessories, fittings. They could be many things. But five main components: controller, pump, supply line, connects pump to the distributor devices, and the distribution itself, distribution injectors, and the feed lines.
Atique, before we move forward, I have a question.
Sure.
Can we go back to the previous? That grease tank, the orange one on the right, when they fill it, What if there is some air entrapped inside the grease? How the system managed to get rid of the air if there is an airlock or air pocket in the grease?
Good question. So the best way is to disconnect the feed line or this if you have an air entrap in, let's say, in the supply line. So first, to answer your first question, so this is just a very small SKF pump in the picture. But for if you have a dual line system, for example, in a steel plant, if you have or in a large paper manufacturing facility, if you have a large steel reservoir, you can either monitor through some devices which can send signal that the reservoir is getting low, the level is getting low. You have to go and fill it, and so different methods. And for the air, the best way is to disconnect the fitting. If you have an air entrapped in the supply line, just disconnect the fitting from, and then just purge with the grease gun. That's the most simple way to remove the air entrapment. That
Okay.
answers your question.
Yes, and how often you recommend that a maintenance team should check the lines? If there is no problem, how often on a regular basis they should do it?
That's a very good question. I think I have something on that question in next slides, but I can tell you one thing here. So this one is a primary valve or the master divider block or valve. So usually when these lubrication systems are installed, there is a pin called cycle indicator pin, CIP, and I think I have that in one of the slides. So cycle indicator pin when the system, and I'll talk about the disadvantage of this type of system, like a progressive system. So you can install a cycle indicator pin on one of the outlets, and then when the system is running, the cycle indicator pin will move back and forth, back and forth. So that's an indicator, and that can also monitor through some advanced advanced monitoring systems as well, because it can send signal that system is working. So that cycle indicator pin will tell you that system is working. Once the cycle indicator pin stop moving back and forth, this means the whole system is blocked. You have to take a look at different things because the biggest disadvantage of this parallel progressive system is that if, for example, if you see my cursor, if this cursor is like, if this outlet is blocked, it will block the whole system. Like if, regardless of how many divider blocks you have in the system, it will block the whole system because they depend on each other. That's why they call progressive. The way they work is the progressive, and I'll explain in the next slides. So the best thing is to install a cycle indicator pin, monitor that cycle indicator pin. You can include that in your regular PMs task, quarterly task, monthly task, whatever is convenient, and then just keep monitoring that. And then other as well, like you will see some errors in the controller. PLC can send you errors. There are so many things.
Okay, thank you.
Thank you. Okay, so here I have, sorry about that, but I have a lot of information, but I'll try to be very precise. So this is a single line progressive system. And just to explain how it works, one of the main components of the single line progressive is air solenoid valve. So air solenoid valve is electrically operated. And this is again a schematic of single line progressive system. There is a pump, controller, master divider valve, secondary divider valve. And then one other thing is FRL, filter, regulator, lubricator. So here you have air supply going into the pump. And then here you have air solenoid valve, which is electrically operated, but it is to monitor air supply to the pump. And then you have supply lines and the feed lines. In air-operated pumps, electrically operated air solenoid valve is mounted on the pump air supply line. So there are two. So in regular air-operated pumps, air is running the pump. Because it's air-operated, as name suggests. And but when you have an auto lubrication system on some components, for example, where you have auto lubrication system on spray on a open gear lubrication for open gear lubrication, you have spray nozzles as well. So in that system, air is supplied not just only to the pump, it is also supplied to the air nozzles as well. But if you don't have air nozzles, then the only component which is getting air or running on air is the pump. So in this system, at a pre-setup interval, controller actuate the air solenoid valve, which allows air supply to the pump air motor, which turns on the pump. Then pump supplies the lubricant through supply line to a master or primary metering valve. And then the master or primary metering valve supplies lubricant through secondary metering valves to the lubrication point. So to keep it simple, this air solenoid valve is turned on by controller at a fixed setup time. And I will explain how we set up those time and how we select these UV valves. So once the air solenoid valve is open, usually they are normally open, I think. When it is actuated, it will allow air supply into the pump, and then pump will run on. It will supply grease through this supply line to this secondary valve, and then this secondary valve dispense lubricant through another supply line to these secondary valves. Sorry, this is primary, this is secondary. Secondary valves, and these secondary valves will lubricate the bearing or wherever they are connected. So why we need so many lubricants? It depends on how many different lubrication points you have. For example, in a regular Caterpillar excavator, you will see lubrication points, pins and bushing from somewhere between 22 to 28 lubrication points, and they are scattered. They are not at one place. So you have to install different metering valves at different locations, but you still have to run one line from one pump. So these divider blocks are the main divider blocks which will receive the lubricant from the pump, and then they will distribute further to the primary divider. This is a master divider block, and it will dispense lubricant to the secondary divider blocks, and they are connected. And the reason is that, for example, you have 22, let's say 22 pins and bushing to lubricate, or the bearings to lubricate on an excavator. So you cannot install just these divider blocks or injectors at one place. You have to scatter them. Like you would have one bank at one location, one bank of injector or blocks at one location. There could be 3 or 4 different banks of these valves. And this is just to increase the outlet or the number of lubricant, number of points to be lubricated. So any question on this one? I think it.
There is no question in the chat, but I have a question. These UV blocks, are they fixed quantity, or you can change the quantity based on the adjustment screws that they have?
Good question. So UV valves are fixed quantities. Andrea requesting to. Yes, Andrea, approved. Thank you. Yeah, so these are fixed quantities. They are not. They cannot be adjusted. And I'll talk about the quantities, how we select these. And injectors are adjustable, and I'll explain why the injectors, how you can adjust the injectors. Andrea, you have any question?
No, I'm sorry. I was trying to take a screenshot and I must have hit something. My apologies.
No worries, I'll send it to you. Okay. Uh, okay, single line series progressive metering valve divider block, you name it. Before I start, you can see, so this is a Greco. This is a Greco metering valve, and it has different number, MSP 10T, MSP 25T, and 05T. And Lincoln would have the same, 5S, 5T, 10T, 25T. And these are basically these numbers, 10T or 25T, they are the dispensing quantities from the outlet. So increase the number. The smallest would be 5T, which would dispense the smallest amount of lubricant from the outlet. And then the highest would be 40S, which would dispense the highest amount of lubricant from one port. When you have T, this means twins. That means it can dispense lubricant from both sides, from this side and from the other side, and you can connect feed lines on both sides. When you have S, there is no S on this one, but there is S available in every divider block manufacturer's offers. And then those S are just single line, single output or outlet. This means they can only dispense from one side, and they would have the largest amount of between T and S. And the other side has to be plugged, otherwise it will not work. So the metering valve operation based on the flow of lubricant. The lubricant flows through the passage of each metering valve divider blocks. The metering pistons move to one side in sequence, like they move like this from inlet to end, each time dosing the precise amount of oil or grease required at the lube point. And before I go in that discussion, let me explain how we select these 10 Ts, 25 Ts, 5T, or whatever. So for example, I'm in technical sales. Many of you are also in technical sale or reliability. So if we have to install a auto lubrication system on an equipment, let's say stationary equipment. So first of all, there would be an inspection of the equipment to identify the number of lubrication points, the size of the machine, how many lubrication points are there, and then we will collect the information on the bearings, like the size of the bearings and the speed, RPM, and the temperature, all those things. Then we will run calculation on the bearings just to identify how much grease is required by those bearings or one bearing per 8 hours. So Lincoln has a formula which is actually for 8 hours lubrication requirement for a bearing, but you can divide that 8 hours to hourly rate as well. And then if, for example, in stationary equipment, you have 10 bearings or 5 bearings, let's say, for example, just 5 bearings. But all 5 bearings have different requirement of the grease. For example, bearing 1 would need the lowest amount of lubricant per hour because it's a small bearing. And then bearing 2 would have higher, and then every 5 bearings that have a different requirement, like they would need different amount of lubricant per hour. So rather installing all 25T, I would assign a smaller for the smaller, like 5T, this 5T for the bearing which required the lowest amount of grease. And I would install 25T or 40T for the grease, which or 40T is the highest. So let's suppose one bearing has the highest requirement for per hour. So I would assign 40T to that grease which need the highest amount of grease per hour. So that's how I will assign different T's, S, and those divider blocks just to give adequate amount of lubricant to each bearing per hour. So they won't starve, the bearings are not starved from greasing. So that's how we select the numbers or the. But for the injectors, which are the parallel system, I can discuss that when we come to that. So valves in progressive metering works in a progressive manner. For piston 2 to move, piston 1 has to move. And what I was saying that if let's say piston 1 is blocked, it will not move piston 2 and 1, and then the piston 2 will not move piston 3. So if a piston get blocked, entire system stops working. And the best way to install, Bashar, to your question, this cycle indicator pin is installed here. And this will, when the system is working, the whole system is working, this pin will move back and forth. Once you see this pin is not working, there is something wrong in the system. And there are so many ways to remove the blockage. You can disconnect the grease line, you can disconnect, you can purge grease from this port by disconnecting this screw and then just purge it. Different ways to remove the blockage. In this one, minimum of 3 valve sections are necessary for valves to operate. You cannot install only 2 valves block and hope that it will operate. It will not. You have to have at least 3 blocks, and the maximum you can go are 8 blocks. Metering valves are custom sized for each application, as I discussed, and CIPs I also discussed. So, any question on this one?
No, I don't have anything in the chat and there is no hand, so.
Okay. No news is a good news. Okay. Single line parallel is the simplest automatic lubrication system. So UV valves or MSP valves from Graco, UV valves are SKF Lincoln, SKF bought Lincoln 10, 15 years ago. So SKF, Lincoln, Elamite are all under SKF brand now. And then we have Graco, Bajor, different manufacturers, and they have different names for their injectors, but the principle is similar. They work on a same principle. There is no difference. So single line parallel system where you have injectors, and there are so many type of injectors. In this one, I have included a picture from SKF dual line system. So components include an electric pump, a controller, injectors. These are the injectors. Pressure sensors. This is very essential. It is necessary for the system to work. Supply and feed lines and fittings, as usual, as like we discussed previously. Each injector serves one lubrication point and can be easily adjusted to deliver a precise amount of lubricant with a high degree of accuracy. So here you will see some screws. They can move. You can move them to. You can open them to the maximum. This and those screws actually will monitor or can be set for the amount of grease to be dispensed from these injectors. So these can be precisely set up for they can be adjusted precisely. And the injectors operate independently of each other. This means if one injector is blocked, it will not block the whole system. The whole system will keep running. You can just simply need to change this one simple injector which is not working and just replace it with another one. Failure of with a single line parallel system, a blocked loop point would not be detected easily at the system level. This places greater importance on regular inspection. So this is one of the disadvantages of this system, that because they don't have any cycle indicator pin, and you have to keep monitoring them. And there are so many things by which you can monitor. But visual inspection is very necessary in this type of system. And as I was saying, this is the pump which you would see on, for example, on mobile equipment, on very large mobile equipments like large haul trucks, you would see this type of system. You won't see a smaller, the previous one you saw, you would see this size of reservoir on. And then when you go to steel mills or large other equipment, the facilities, you would see larger reservoir because they would have a dual line system.
Take, may I ask a question?
Sure. Yeah.
So, what about these piping sizes? You know, how do you size the tube and pipe for the, like, you look at the energy I or the pressure, or what do you do?
Yeah, good question. So for the greases, we do the pipe sizing and like their flow rate, and we have some calculation, and I believe every manufacturer would have some calculation on that. Like we calculate on how those greases will flow in different pipe sizes. So that for the greases, but for the oil, it is depend on the length of your system, like how farthest you are dispensing the oil and what pipe sizes you are using. So there are calculations for calculating the pressure drop. So every connection, including fitting, pipe size, pipe diameter, they will reduce the pressure. So for example, if your pump is dispensing, let's say 5,000 PSI of pressure, and your distance to dispense that lubricant is, let's suppose, 100 feet far. It's a big distance. So in that 100 feet, you would have pipe, you would have fittings, you would have headers, you would have drops, and every connection would reduce the pressure. So for example, you did not calculate and you dispense a lubricant 10W30, 15W40 for 100 feet, and without considering the pipe diameter, most likely you won't get the required pressure at the end of the line. So everything has to be considered when deciding what type of lubricant you are using, how far you are dispensing, what pipe diameter you will be selecting, what type of fitting you would be selecting, if you even need a fitting, or you can just curve the pipe and just get it flow. Because if you have a T, it will reduce pressure more than if you have a curve or like a bend in your pipe. So, and everything is need to be calculated before you decide for, and if you see any interest, maybe we can do another presentation some other time for those designing
Sure.
stuff.
Thank you very much. Sure. Thanks.
Okay, so single line parallel, and many injectors you can see here, Lincoln, Graco, and there are so many other manufacturers, but these are the main one. And so a pump, the way they work is a pump pressurizes the main supply line and fills injector. These injectors. Injector deliver the lube to the point. At the same time, pressure is built up in the main line, and system is hydraulically closed, which cause pressure in main line to rise until the preset pressure at pressure sensor is reached. So going back here, I was saying that this pressure has to, like, we have to have a pressure sensor. So what it does is basically, this is a small picture. It doesn't show anything about the size. You can, like, the larger size of these. For again, let's suppose if you are running this system to farthest 50 feet, 50 feet of machine, like it's a big machine and you're running this system farthest to 50 feet, and you have to have a pressure, let's say 5,000 psi, and you calculated that the pressure drop through the lines and everything would be 4,500 something, and at least for the farthest, you need some pressure. So the farthest point, loop points can be lubricated. But if you lose pressure everywhere in the system, then the farthest lubrication point cannot get enough grease or oil. So it has to maintain the pressure. The system has to maintain the pressure so it can take the lubricant to the farthest point. So that's why these pressure sensors are installed. They monitor the pressure. And for example, we calculate that for the farthest, we at least need 2000, like 2500 psi of pressure. So that's how those dew points at the end would get the grease. So this pressure sensor is set up to detect 2500 psi. Once the 2500 psi is reached in the line, it will send, this pressure sensor will send signal to the controller to shut down the pump, and the controller will shut down the pump. This means that this is just to sensing the pressure, just to make sure that the farthest point, farthest greasing points are getting the enough grease by maintaining the grease pressure. So this is exactly what it is saying here. Pressure sensor then send a signal. Pressure sensor is mounted in the main line prior to the last metering device. Pressure sensor then send a signal to the controller or PLC once the preset pressure is reached. Now the pressure relief valve relieves the mainline pressure back into the grease reservoir. So one more thing, as you can see, this is a different setup than the progressive one because it's need a venting. And so this is a pressure relief valve where my cursor is. It is just to make sure that the pressure is relieved back into the reservoir so the system can complete the next cycle. Two types of system based on injector type, pre-lubrication and relubrication. Pre-lubrication deliver lubricant at the same time when pressure is built up. Relubrication deliver lubricant when after pressure is relieved. So the more common as injector blocks you will see in the industry are SLVs, SL1s, and they are all pre-lubrication injectors. They actually lubricate once the pressure is built up and built up in the line. They will dispense and lubricate the bearings. But there are some SKF 350Cs which actually lubricate once the pressure is relieved. Any question on this one?
Nothing in the chat, no.
And Vashad, on your question, these are the screws. These are the screws where my cursor is.
Mm-hmm.
And you can adjust the output. So this is the outlets. You can connect your feed lines here. And if you open them completely, this will dispense the maximum output. If you close it to the maximum, then just it won't dispense. So these are the dispensing adjustment screws.
Thank you.
Dual line systems. Dual line systems system is the most robust system and provides advantages of application covering great distance and large number of loop points like in steel mills. So the main purpose of dual line systems is, for example, if you have 1,000 lubrication point and in steel mill, walking beam furnaces, large facilities, you would see extremely high number of lubrication points. So let's suppose 500 loop points, 500 lubrication points, 500 bearings to be lubricated. So you cannot connect all 500 lubrication points on single line because that will be very, it's a big burden on lubrication system. So what these system will do is that you can connect 250 points on one line and remaining 250 points on another line, line A and line B. So 500 points will be distributed connected to line A, like 250 on line A and 250 on line B. So that's why we have these dual line systems. Component include pump unit, like mostly you will see Peugeot Delamon systems, Lincoln ZPU pumps, this blue one, and these are the pumps you will see in a very large settings. High operating pressure up to 5800 psi's, and then you have a changeover or reversing valve. This is a unique component for dual line system, and some example are Lincoln EMU, and then you have dual line metering devices. These are still the same progressive lines, but they have larger output, and you can still connect smaller SV blocks like Lincoln SV blocks or similar Greco blocks, but these are the more preferable metering devices for the dual line system. And then you have end of the line pressure. So one thing you will notice that this is also a dual pressure pressure sensors. It will do the same purpose. It will. Okay, Khalid, thanks for attending. End of line pressure sensors, same purpose. They will sense the pressure at the end of the line. And then you have control unit, then tubing fittings. And again, control unit could be a standalone controller, and you can also control them through PLCs. Okay, so how this system work? The pump generates pressure in the first line. At the same time, the system releases air through the second line. So at one time, line A is working and the line B is just venting the air. The venting of the second line creates the necessary pressure in the first line so that the lube is delivered through the tubes to half of the system's lubrication metering devices. Remember, like 250 lube points are connected with line A. So in this cycle, line A will lubricate 250 lubrication points. The other half of the metering devices are connected to the second line. The pressure built up in the first line is monitored through pressure sensor. Again, the pressure sensor is installed before the end of the last metering device, just to sensor that the end of the line bearings are getting greased through maintained pressure. The pressure built up in the first line is monitored through pressure sensor mounted in the main line prior to the last metering device. Once the lubrication is delivered throughout the first line, the monitor initiates a changeover to the second line through a changeover valve. So again, this controller is the governor, as we have governors in steam in turbines. This is the governor here. It will govern which line will operate and which line will vent. And when it's time to change, when the pressure is reached at the end of the line, it will send signal to the changeover valve, and the changeover valve actually just change the line, and the action will be reversed. So line A will become the vent line, and the line B will become the line which will dispense the lubricant. At this point, the first line is vented, and the second line builds up the necessary pressure to deliver lubricant to the remaining injectors, and it goes on and on and on. So this is how the dual line systems work, and I think that is the last slide I have. So I will questions or comments.
Okay, thank you very much. Thank you very much. Yeah.
Sorry, I hope I did not make it too difficult to understand, because I know it's a vast subject. And any question, please.
Well, I don't have any. I have a couple of comments that probably you read them yourself. Khalid had to leave, and Brian had the suggestion for the next virtual meeting on the air oil consideration. So about the pump, if before we start, I ask a question: what if a company wants to switch from one type of grease to the other type? What they should consider? Like both of them are Energy i2, but one of them is lithium complex, the other one is calcium complex sulfonate. So what consideration they should take to switch from that grease to the next one when the energies are the same?
Good question. Um, so you have to consider, and your question is more relative, more about the different thickeners or just the same?
Well, what I hear a lot of time is like calcium complex sulfonate are not good in the lubrication systems. If you want to do it, you have to size up the pipings and fittings and stuff. Or you have to put a heat trace on it because for the winter they will plug the system, something like that. So I want to know from your point of view, is it true or people try to be more cautious on that?
And then again, it depends. Good question. It depends on the length of the lines you are running and how exposed those lines are to the temperature. For example, if you are running a line outside somewhere which is exposed to -30, -40, you definitely need to have some sort of heat tracing and the drum cover as well. But usually, usually you have to change greases, different greases in different temperatures, summer greases, winter greases, if the equipment is running outside. But if you are changing, to your initial question, if you are changing grease to grease, sorry, hey Luke, how are you, man? Sorry, I just saw my old friend Luke. How are you, bro?
Hi.
Long time no see.
Yes.
Okay. Hey, Benan as well. So yeah, so you have to yeah. So if you are changing from one thickener to another thickener, keep in mind that these auto lubrication systems are total loss lubrication. So total loss lubrication mean it will just purge the old grease from the lubrication points. So the precautions you have to take is just minimize the reservoir to minimum. Like consume the grease. For example, if you are changing grease from one thickener, lithium to calcium, they're borderline compatible, as you know. They are not fully compatible. And then you just minimize the reservoir with lithium complex grease and just fill calcium. And the reason is that even though they are not compatible, the new grease will purge the old grease out completely. You don't have to even change the the settings, because again, it is a total loss lubrication and it will purge out. But if you have somewhere where the grease cannot be purged, you have to take caution. So that's something that is very important when you are changing greases.
But you don't see any changes in the hardware. We shouldn't change the diameter of the pipes or something like that. You're just cautious about the compatibility of the two greases.
So two things. One thing is the mobile equipment, and one thing is stationary equipment. So stationary equipment, you can still use the same piping, but you have to do the calculation first. Calculation mean then you just making sure that you can dispense this grease to the furthest, whatever the furthest is. And for example, calcium, as you explained, calcium would need more pressure. So you can just increase the pressure, because sometimes if you have long lines, like a very old system, it would be a nightmare to change the piping, because the pipings may have been done long time ago, and it is costly. So different things. First, you have to check, even if your calcium sulfonate would run in that big system, if it does, then you have to just increase the pressure by increasing the input of the air, or just adjust the pressure to max or increase whatever needed. But on the mobile equipment, no, you don't have to change lines. Well, like not all the time. Maybe sometimes, but not all the time.
And I promise that would be my last question. A couple of times you mentioned calculation, and it seems that
Yes.
these OEMs, they have their own calculator that you enter the data and get some feedback. So my question is, have you seen somewhere in that calculator talking about the type of the soap of the grease, or that's mostly about the NLGI and basal viscosity? What kind of data from the grease point you put into that calculator to get the calculator run?
So the NLGA is the most
Mhm.
important thing when you are selecting a grease, and that's what I was saying. When you have, for example, mobile equipment, we all deal in mobile equipment, heavy equipment, Caterpillar, Hitachi, all those big equipment. So those equipment they run in both weather, extremely hot, extremely cold. We It is best not to use one grease throughout the year. If you have a grease which can be used throughout, that's an amazing thing. But mostly when we have extremely cold weather, like -40, -45, one grease will not serve that purpose. So you have to have, and I know all of us have different greases. So the best is to change greases at that time, like summer greases, winter greases, but NLGI is one. So what I was saying is that for winter, the NLGI would be somewhere around 0 NLGI,
Mhm.
00 NLGI. So it's mainly NLGI. And when we use the thickeners are mostly dependent on the application. So the best application for water resistance, like a water resistance application where the bearings are exposed to high amount of water, the best would be the calcium sulfonate or calcium complex. And then the lithium would be just ordinary grease and the regular grease. It won't serve better than calcium in when you have water resistance application.
Perfect. Thank you very much. Well, I don't have any other questions. Is there any other questions in the audience, or Solongo, you wanted to add something? Okay.
And if there is any interest in learning about lube dispensing, how what I was saying, calculation and designing, lube dispensing designing, let me know. Maybe we
Sure.
can set up sometime. But I know
Okay.
it's a dry topic, so I don't know if anyone is interested.
So we have a question. Patrick says, what is the role of smaller automatic grease dispensers, such as those from the ATS Electrolube brand, in the
Yes.
overall picture of the automated lubrication, in your opinion? How is it relevant for the heavy industry or smaller corporations?
Good question. So, if I'm not mistaken, you are asking single point auto lubricators, right?
Small. Yes, you said
Single, okay.
yes.
Yes, okay. So single point auto lubricators are just a single line. Like they are, like you mentioned, ATS. So ATS is a brand, and Perma is a brand, and there are several other brands you can use. So it is just to like where you cannot run large equipment, large auto loop systems. You cannot run the lines because equipment is moving and there is no space to have a hydraulic hose or the steel tubing, whatever. For example, an electric motor. Electric motors are cannot be installed with auto loop systems. So the best option is to install single line auto lubricators. And those single line auto lubricators you can keep them running for a month, 3 months, 6 months, a year. So what they do, they do the same thing as other lubrication equipment. They dispense a precise amount, um, um, like for example, electric motor bearings, they don't need lubrication very often. Some electric motors can only be lubricated once a year. Just an example. So same purpose, single point lubricator are the best where you cannot run the large auto lube systems. And for example, if the same system which you are planning to use for one month, it will dispense the same amount of grease, but it will dispense very quickly, so it can empty the can in 1 month. But if the same system, same or single point lubricator, if you install it for, let's say, set up for 6 months, it will dispense a smaller amount, like the same amount, but very large duration. So it can keep, it will dispense the whole cartridge in 6 months. So I don't know, Patrick, if this answer your question, but the same purpose cannot. It's only used where the main systems cannot be installed.
Good, perfect. So I don't have any other questions here. I want to thank you, Solongo. If you want to add something to the meeting, please unmute and speak. Otherwise, yes, go ahead, Solongo. And we can't hear you if you're talking.
Sorry. Yeah, just wanted to say thank you as well to Atique and also to the attendees, and to just keep your eyes out peeled for our next technical meeting, which will be held in October. And then just so you know, we have a very interesting lineup for the next year, the 2024-2025 year, including a tour as well. So just as well as a mix of virtual and in-person meetings. So keep an eye out for those. And thank you, Beshad, also for your hard work.
Oh, my pleasure. Okay, on behalf of STLE Toronto section, I want to thank you, Atique, for the great presentation and the time that you dedicated for us. As Atique said, if there is any question, you can communicate with him directly or communicate with anybody at Toronto STLE section. So we will pass the question to Atique and we'll provide the answer. And this will conclude the meeting. Atique, do you want to add anything before we go?
No, just thank you for attending and thank you for this opportunity for presenting.
Oh, thank you very much, everybody. Have a great day. Bye now.
Thanks. Bye.